I studied physics and oh, was it hard. Whenever I told people about my studies, the reactions were always similar. I'm glad I got rid of physics in school. That must be so difficult. Or, wow, that's so interesting. I wish I could do that, but I'm not smart enough. So, seems like everybody thinks learning physics is hard. But why is it like this? Does it have to be this way? And what can we do to make physics feel less hard? I like to blame others for my problems, so let's start with that. Let's blame society. In our society, we still tend to picture scientists as nerdy geniuses, an exclusive club you can only get into if you were able to do calculus already in preschool. But it's not like that. And this picture comes with some problems. People feel like they don't belong to that group and conclude that they can never learn physics. They are scared that they're not smart enough. And yes, I have to admit I've met physicists I'd call seriously brilliant, even if they would never agree on that. But, in my opinion, learning science is way more about dedication and getting the right kind of support than about being smart or gifted. So, if we try to let go of our preconceptions and learn physics, it's still hard. But why? Let's see why learning physics actually feels so hard. I want to point out two common reasons, or rather misunderstandings, that tend to intimidate people or make them feel dumb, which hinders relearning and keeps them stuck. Physics wants to cover everything, the whole universe, but extremely reduced, at an extremely deep level. What do I mean by that? If you ask a biologist what humans are made of and what leaves are made of, you'll get two different answers, I guess. In physics, both cases, the answer is atoms or fundamental particles. So, in contrast to other sciences, explanations in physics are at a very fundamental level, close to the basic laws of nature. This has two consequences. First, physics can be less intuitive than, for example, biology, because it deals with concepts far from everyday experiences. Imagining water being pulled through a leaf is simpler than visualizing a quantum particle which is in multiple locations at once. That's a shame, because we humans just love visualizations. We are inherently visual and we are storytellers. We want analogies and metaphors and we want pictures. And then we get this. I mean, it tells me that the particle somehow takes to different paths at the same time, but it doesn't help me to understand. So, we don't have good illustrations, and then these illustrations are even misleading. That's the picture of an apple. If you didn't know anything about apples, you could conclude that apples are always red, but they're not. You know that because you have an intuition for apples, but you have no intuition for, let's say, space-time. This is not space-time. This is just an illustration that wants to highlight that space-time is curved. If you try to make sense of space-time by looking at this image, it's gonna be misleading and frustrating. There is a better analogy for why space-time is shaped the way it is, as I explain in this video. But every analogy, every image has its flaws. It's incomplete. And if you lack an intuition for the topic, understanding becomes challenging. And we do lack intuition, because physics works at such a fundamental level. This level of depth actually allows us to make highly precise calculations and predictions. But this is the next reason why physics can be so hard to learn. Because that's why physics is so closely tied to math. People don't like math because they look at a formula and they're like, what? What does it mean? And then they feel stupid. But those are just a few letters and symbols. They have no meaning. If I only show you this, you cannot know what I'm trying to say. They only get a meaning if I tell you what they stand for. The letters are just abbreviations, and you need a legend to make any sense of it. So, let me tell you that these letters stand for this. Now you can guess what I'm trying to say, and you may come close to the solution because you have an intuition for fantasy, but you can't know it. I mean, what kind of numbers are magic and adventure supposed to be? How do you get them? And what is the resulting number fantasy telling us? The letters in physics formulas are usually abbreviations for technical terms or specific terminology. These technical terms are, in their own way, also abbreviations. So there are different levels of abbreviations. For example, this could be a formula telling me if a book is a fantasy book. Magic and adventure could be technical terms that are 1 if the book contains some sort of magic or adventure and 0 otherwise. But it's not enough to know these technical terms. You also have to know how the math works. Basically, you have 2 different languages you need to learn to make any sense of this. Only then you can know that F is either 1 or 0. And if it's 1, it's a fantasy novel. This formula can be put in simple words. Does the book contain magic? Yes. Does the book tell about an adventure? Yes. Then it's a fantasy book. Unfortunately, in physics, putting a formula into words is usually long. Because in physics, formulas are meant to represent as much information as possible as concisely as possible. Physicists don't like to talk a lot, so the explanations of formulas are usually also as concisely as possible. So, don't feel bad if you don't understand it. You probably just haven't uncovered all levels. You don't know both languages. You simply don't have all the information. But you need all the information to have at least a chance of understanding what a formula represents. So, formulas are as concise as possible, and their explanation contain multiple levels of abbreviations. If you don't have all the information, if you don't know the technical terms, you can't understand what's going on. Unfortunately, often only the first level of the explanation is shown. When you combine that with our lack of intuition, it's no wonder that we often misinterpret the levels shown and misunderstand technical terms. That's why we don't understand what's going on and end up being frustrated. Why do we often only see the first level of explanation? Because the deeper levels are getting huge. That's because physics tries to cover everything with as few formulas as possible. Let's say I want to expand my formula to not only cover books but also movies. But my standards for what counts as magic or adventure vary depending on whether it's a book or a film. Are special words shown or special scenes? Then my explanation would suddenly get way bigger. Being so immersed in the topic, I'd likely assume people get what I mean and simply use an abbreviation again. This allows other experts to read my formula more quickly, but it makes my formula harder to understand. Alright, that was quite a demotivational speech about why physics is so hard to learn, but does it actually have to be that way? Partially, yes. Just think about it this way. Physics tries to describe our whole world. That's really complex. And physics is already trying its best to be as simple as possible, which comes at the cost of introducing technical terms, abbreviation and formulas. Yes, that makes it more difficult for people to learn physics. But it makes it way easier for researchers to actually do physics. And it's prettier, at least in the eyes of physicists. So, what can you do to make physics feel less hard? Don't take illustrations or analogies too serious to avoid misconceptions. Always try to understand what they are trying to tell you, which aspect they want to highlight. This image, for example, wants to highlight that the mass of the Earth shapes space-time. And that's basically it. Without knowing what aspect this image wants to show, it's just a set of lines forming a grid. This is important. The image wants to show you something. If you don't understand it, it's not because you're dumb, but because the image cannot show it. Maybe the image is not good enough, or maybe you are missing informations. Try to get more information. Try to understand what aspect the image wants to highlight. Furthermore, a single image can't show you the world. So, look at multiple illustrations and analogies to understand different aspects. If you look at a formula, remember, these are only abbreviations. You have no chance of understanding an equation if you don't know what these abbreviations are supposed to mean. A formula like this is pointless. You need its legend to make any sense of it. And even if you got the legend, the description of these abbreviations are probably abbreviations as well. So don't feel stupid if you don't get it. You're trying to decode a secret language that's only been partially translated, but just into a foreign language. A foreign language that likes to keep it short. Very short. So, don't call yourself stupid if you can't read it. You're just missing a dictionary. And another one. And practice and experience and digging deep into it and thinking about it the whole day and sometimes night. I mean, that's what scientists do. And along the way, while trying to grasp it all, they eventually have to come up with new words. new abbreviations that make sense to them but might be confusing to others. Wait, not might be confusing, but will definitely be confusing to others. So, can you still understand physics if you're not thinking about it the whole day? Absolutely, yes. You don't need to be a genius. You just need explanations suited for you. Hopefully you find some on my channel, so please subscribe. And if there's any equation you want me to decode for you, leave me a comment below and I make a video about the one that gets the most likes. If you are studying physics, my best advice is to unite with others. There's no need to go through this alone. It's much easier to understand things if you're not on your own. And it's also way more fun. Meanwhile, consider that you are uncovering how the world actually works. Of course that's complex. It doesn't say anything about you intelligent if you don't understand it the first time, or the second, or the third. You are not fluent in those languages. And that's alright. You just need explanations better suited for what words you already know. You probably haven't come across a helpful analogy yet. You haven't uncovered all the levels yet. If you want to uncover different levels of gravity, watch this video. Please subscribe and like if you found this helpful. Thanks for watching.